Hey, it's Alex from Inside Gadgets, and today we're continuing the series on how to make a flash cart. From the last part, we looked at the connections required for a 32 kilobyte flash cart, and today we're going to look at how to actually program that flash chip. So we have the flash chip commands over here, and the ones that we're interested in is the chip erase and the program. As the chip erase says, it erases the whole flash chip, and the program allows us to program one particular byte on the flash chip. Most of the flashes these days will already support a 32 kilobyte chip, but it's good to have an understanding of how it all works. When you receive a brand new flash chip, all the bytes are unprogrammed, which means that they read as FF. And that's the same thing that the chip erase will do. The way flash chip programming works internally is by changing ones into zeros. So if we wanted to write a 1 instead of an FF here, the flash chip would change all of these ones into zeros, and we would be left with 1. And it's possible to reprogram the same byte again as long as you're changing the bit from 1 to 0. So we could tell it to program 0 and we would get 0 in return. So let's pretend that the flash chip already has some contents on it and we wish to erase the whole flash chip. How do we actually do that? We do that by following the command set here for the chip erase. So the first step, according to the datasheet, is to write 555 to the address lines and AA to the data lines. Then we can pulse the CE pin and also pulse the WR pin, and that's our first bus cycle. So for the second one, we just need to do the same thing. So we would be writing 2AA to the address lines and 55 to the data lines. We do the same pulse with CE and with WR. And then we just advance to the third step, and then the fourth step, and then the fifth step. And once all those are done, the flash chip will begin the chip erase cycle. Flash chips have different erase times, and that just means how long it takes for the whole chip to be erased. Sometimes it takes seconds, and other times it can take a minute or two. It does depend on the size of the flash chip. While the flash chip is being erased, you can check the status of it just by reading address 0, and it will come back as FF once the chip erase is complete. So you would just set up address 0 and then just pulse CE like before, and this time pulse RD for the read. So once the flash chip has been erased, we can go into programming it. It's a similar thing as before. We just write the address down and the data and pulse CE and WR like last time. So the fourth bus cycle is where we specify the program address and the data. So let's say we want to write to address 0 and the data of 1. It'd be the same thing. We pulse CE, pulse WR, and then we just wait a couple of microseconds. Usually it's about 10 microseconds or less. Like we did with the chip erase, we can just read the status of how the program's going just by pulsing CE and RD like before. We just specify the address as 0 and then we just read the data back. So once the data comes back as the one we programmed, so 1 in this example, then we can move on to the next byte to program address number 1. So for the next byte to program at address 1, we simply do the same program instruction command set, and then once we get to the program address, we specify 1 and the data we want to write, so let's say data 2. And we would do that for all the addresses on our flash chip, and for us it's just 0 to 7FFF, which is 32 kilobytes. And that's how we can program a flash chip. Some of the flash chips do have special commands that let you know what the manufacturer ID and the device ID of that flash chip is. I refer to this as the flash ID, and it's an easy way to know if the flash chip is responding to what you're sending it. To read the ID, all we need to do is do the same command instructions as before, and so we would read from address 0, and we would expect to see the data 1 in return, and then we can read from address 1, and we'd expect to see 0x20 in return. Once we're done verifying the flash ID matches, we need to exit the flash ID state, otherwise we're stuck there. So to do that, we just simply reset the flash chip. So at any address, we just write F0 to the flash chip, and then it will reset back to read mode. And that's how we can erase and program a flash chip, as well as reading the flash ID. On the next part, we'll look at MBCs, also known as memory bank controllers, and that will allow us to go past the 32 kilobyte limit. Thanks for watching.